Next, we will have totally eight applications to cover. We will cover from the most fundamental ones, and then to the emerging one or the new ones. The new ones are voice over IP, streaming, and P2P. Okay, but before that, we need to see the fundamental ones. And the fundamental ones start from the DNS, domain name system. We like to see how it works. We need to see check the domain name space and also zone and name servers and zone data file and resource record in a name server. And then these are all the terminology that we need to get familiar with. And then we look at how a name query is resolved. We look at the process of resolving the name queries. So there'll be resolvers and the name resolution process. Either resolving a domain name into IP address or vice versa from IP address to domain name. So we can do either way. And we need to know the process. And at the end, there's an open source package called Bind. We look at the implementation of this. So domain name system, you're probably familiar with the DNS that you use every day, because and in fact you should, because you use it every day when you key in a domain name, and without having to memorize the IP address of a website or a or a mail server. You don't have to memorize the IP address. In fact, it will be nearly impossible to memorize when we move from IPv4 to IPv6. You could memorize IPv4 address, but it's too difficult for you to memorize IPv6 address. So all you need to memorize should be the domain name instead of the IP address. Not to mention the MAC address. Okay, and the domain name space is organized into levels. And the top level domain will be something like this. And com, org, gov, edu are the more common domain top level domain. So a domain namespace will be organized as this, with the root domain covering edu, com, and org, gov. Most of them are US-based domain name. However, if a top-level domain does not come with a country code like TW, UK, it doesn't mean it is in US. So if you see some domain name, top-level domain name with .edu, .com and .org, it's not necessarily based in US. It was based in US, but now you could apply a domain name without a country code, at the end. So even though you are not in US, Okay, and then the country code, two character country code is also at the top level, and then under that you would see .com, .org, .edu. So in this example, it's the computer science department under National Jiao Tong University, under EDU, under TW. And the advantage of having this kind of organization is it could be distributed from the root to different levels, and it would distribute the load to process queries. So in fact, then each node in the domain name tree could be handled by one organization. So each organization can have its own name server, and at the top you will see a root name server, and there are totally 13 root name servers. 13 root name server distributed worldwide. If you see the book, there's a table listing all the name servers, root name servers worldwide. It's on page 434. Page 434. There's a table on page 435 listing all the root name server. And each name server, in fact, could have multiple server machines because the loading is quite high. So for each server, you could have multiple machines to handle the queries. Oh, okay. That's the top level. And then under the root name server, each node in the domain name tree could be handled by a name server in an organization. So here are some terminology to clarify zones and name server. So some difference between the zone and domain. And a zone would contain some part of the domain name space, while a domain is a subtree in the domain name space. So in the sense that a domain can contain multiple zones, and a zone could also contain multiple domains. And so what's the purpose of having zones? It's for a name server to manage. Okay, so a name server can manage a zone, and a zone does not necessarily imply one single domain. It could be multiple domain or a subset of a domain, and the domain and the zone file or the zones will be managed by a single name server. Okay. So what you need to do is that you put one or multiple zone data files. Okay, data file of a zone or multiple zones into a single domain name server. And within the zone data files, there are resource records. Which describe the host within that zone. So each file describe a zone. Okay, each file describe a zone, and within the file, there will be resource records. And there are 6 major type of resource records. Okay, these are the type of resource record, and what they stand for is this. Okay, let's look at this first. The resource record. So within each zone data file, there are resource record, and totally there could be 6 types of resource record, and it could be a SOA, startup authority. It describes who the name server is for that particular domain. So this example says that for this domain, its name server is this. So I'm specifying the authority domain and name server, or the best name server. Or I can specify, because I could have multiple server for that domain. I could have multiple server for that domain. So I could specify multiple name server. For example, I'm saying for this domain, this is a name server. So if I have both of this, I'm saying this is also name server, and this is the best one, the representative one. Okay. And the resource record A will stand for will be used to map the domain name into IP address. So I'm saying for this particular machine with this domain name, its IP address is this. And if this machine, if this host has multiple IP address, I could specify multiple. In this example, I specify 2. And it looks like these 2 are on different subnet. So this machine probably still hosts multi-homed. Multi-home meaning it's connected to more than one subnet. In this example, it connects to 2 subnet. Okay, so the A record is for forward query that you look up the IP address from the domain name of a host. And then you would have the PTR record, pointer record, which is for reverse query from the IP address to domain name. Okay, so I'm pointing address, IP address into domain names. So this is my IP address, but described written in the reverse order. So this is the IP address 140.113.23.10, but it's written in a reverse way. So start from the low order byte to the high order byte. And it's written. It's a convention. It's a convention to write it in a reverse manner. So I'm saying this IP address I would translate into this domain name. So if you know the IP address of a machine, of a host, but you don't know the domain name of this host, you can send a query to the name server, to your name server, and eventually you will get the domain name of this host. And the name server give you the answer by looking up the PTR record. The PTR record. Okay, there are 2 other resource record. One is a canonical name. It's saying the canonical name of the domain. So I'm saying this is my canonical name. I could have some other alias name, but this is my canonical name, or my major formal name. But I could have multiple alias names. Okay, that's the purpose of canonical name. C name. Another resource record is MX, mail exchange. So I'm describing the mail server of this domain. Mail server of this domain. And I could have multiple mail server for this domain. So for this domain, I have a mail server of this. And I could have another mail server of this, but then I would specify my preference, 0 and 10, for example, and the lower number would means the preferred, more preferred mail server. So for this domain, I have 2 mail server, and the preference is described in numbers. So so the resource record, as you can see, describe who the name server is, and the forward query from domain name to IP address, and reverse query from IP address to domain name, but IP address should be written in the reverse order, and the alias name and canonical name, and also mail exchange for that domain, mail server for that domain. Okay. So that might well, if you feel a little bit confused, don't well, just try to figure this out piece by piece, and then you will get familiar with it. And a name server for a zone would have a master server and slave server. So for a zone, I could have one master and several slave. Sorry, one master and several slave, and that's for the purpose of higher availability and better load balancing. And I could do zone transfer between master and slave, so that if there are some update, I can synchronize the zone data files. So this is an example within the namespace, domain namespace, where there are 2 zones, zone A and zone B. And for zone A, we have a master and a slave name server. For zone B, we also have a master and also a slave. And this particular host happens to be the master name server for this zone, and the slave server, name server for another zone. And within the name server, you would have zone data files which contain resource records for that particular zone. Okay, and between slave and master, you could do zone transfer to synchronize the data file, zone data files containing the resource records. Okay, so we mentioned that in handling the query to name server, there'll be 2 kinds of queries. One is forward query, another is reverse query. The one forward query handles from name to IP address, while reverse query handled from IP address to domain name. And the resolution method could be iterative or recursive. Remember that we have root name servers, 13, totally 13 worldwide name server distributed globally. And under the root name server, there are many levels of name server, and each level each name server is put into an organization in charge of managing the domain name space under that. And so you will see that the domain, the query resolution, name resolution process is distributed, quite distributed. Your local name server, first you ask your local name server, but your local name server would not know the answer you need. Okay, so your local name server would need to ask around. And the way your local name server asks around is either iterative or recursive. And you will see that recursive is too difficult to achieve, because the name servers need to be stable. So it's too much load for the name servers. So it's less likely. So the commonly adopted model is iterative. So we will see that process. And once you get your local name server got the answer, it will cache the answer for a certain time. Okay, so that it would not ask again next time somebody else asks. But the cache entry needs to expire. Otherwise, there might be some consistency problem. Okay, so here's the name resolution process, and it's iterative, and I'll explain what happens if it's recursive. Okay, so first of all, that's the client program. Here's your client program. For example, a browser, or any program you write, any program you wrote that require networking. So your client program, you input a domain name on the client program. Okay, so the client program needs to translate the domain name into IP address. So what it does is to ask the local name server. It asks the local name server, and your browser or your application client know the name server, the local name server, because of what? Mostly because of DHCP. So you got the name server from the DHCP server, so that your DHCP server tell you who your name server is. So you know where it is. So you ask the local name server. And you ask the local name server about this because that's the domain name that user key in. The domain name you key in is this. It's something, some host in UK. And of course, your local name server does not know anything about UK. So what it does is it asks the root name server, which is one of the 13 global name servers, root name servers. And the root name server does not know either. So, but it knows the UK name server. I mean, it knows the name server which is in charge of the UK domain. So it would tell you, okay, it will respond telling you, okay, you should ask this name server, which is this. So you know the IP address of the UK name server. So you ask UK name server about this. And the UK name server say, okay, I know UK, but I don't know GOV and anything under GOV, but I know the name server in charge of the GOV. So it reply with the gov.uk name server. So again, you ask gov.uk name server, and then the gov.uk name server say, okay, I don't know things about under DTI. This is the government organization, but I know the name server of the DTI organization. So I would tell you, please ask the DTI gov.uk name server. So I would ask, because I know the IP address of the dti.gov.uk name server from this guy. So I ask again. Okay, and finally, this name server has the answer, because www.dti.gov.uk is managed by this name server. So it looks up its zone data files. It looks up the resource record and find out, okay, and look for the A record, the resource record, A record. The A record stands for the from domain name to IP address. Okay, so from the A record, it got the IP address, okay, for that domain. So it is sent it back. So now the local name server got the answer, and actually it got two answers with two IP address. So it returned the client with the two IP addresses. So now your browser, if the client is a browser, your browser know the IP address, and there are two, so it connect to one of them. Okay, and why do we call it iterative? Because all these name server, they don't memorize anything. They just handle the query and then forget it. I don't memorize anything. I just redirect. So what they did is just redirect. They redirect the local name server to another server. Okay, and after the redirection, they don't memorize anything. Okay, and it's iterative. What if it's recursive? If it's recursive, the query flow wouldn't be like this. It would be like this. I ask this local name server, the local name server asks the root name server, and then what? The root name server will then ask this name server, and then this will ask this, and then it asks this, and then the answer propagate back. If it's iterative, then all the query, all the name server just redirect. They don't memorize anything. But if it's recursive, then they need to handle my request. I just ask the root name server and wait for the answer from the root name server. I don't ask the other server. It should be the root name server who asks UK name server, and UK name server asks gov.uk, and then by continuously until you get the answer back, all the way back, and then get back the answer. So that's recursive. And if it's recursive, as you can see, the number of queries processed by each name server is very large. The number of queries is large. I don't have the number, but it should be at the root name server. It should be millions of query per second. And if you turn that process into recursive, then that means I need to memorize, say, for example, if a name server needs to process 1 million query per second. and each query takes 2 seconds to process. Then I need to keep each of the query for 2 seconds, and so totally I would need to queue 2 million queries in my memory. 2 million queries in my memory. Okay. And if it's not just 1 million, could be 10 millions, then you need to queue 20 million queries in the memory. So that's a lot. Okay. And the loading will be too high. And so it turns out the iterative mode is easier for the servers, name servers. However, it's the local name server who should do most of the job, while all the others just do redirection. Okay. Questions? Any question? So that should be clear, right? Iterative mode. Okay. And as we mentioned in a general issue, that the application protocol message are variable length and format. But there's one exception. DNS is one exception. It was designed early, and they still try to design a fixed header format, Not many parameters, so they write it this way, with a fixed header, and then followed by the query, the answer, authority, and additional. So these are the query we send. You might look up from the domain name to IP address, or IP address to domain name, or you look for mail server, mail exchange. You look for canonical name. So these are the things you put. But there's a count. There's a counter that will count how many question is put in the message, how many answer you put in the message, how many name server you put in the message. So there's a counter here. So it's quite kind of close to fixed format, and this in the header. But after DNS, they realize it's difficult to try to have a fixed header format. Even if you have fixed header format, even this is fixed, this won't be fixed. Because, for example, the answer you put is either IP address or domain name, and it's variable length. So this could be fixed, but this won't be fixed. So later on, when they design the other application protocol, they totally give up the idea of having a fixed part in the message. Okay. The open source implementation for bind, it's I think I missed one figure. There's a figure in the book describing how to become concurrent. How to become concurrent with the design of worker thread model. So if you look at page number 438, okay, because the program, the bind program has evolved evolved many times, and now it's version 9, bind 9. It's a multiprocessor. I mean, it supports multiprocessor with the multi-threaded implementation, concurrent multi-threaded. So it's a concurrent multi-threaded implementation, and that can support multiple processor. So with in a platform with the multiple CPU, it would run the thread distributed on the multiple processors, as shown in the figure of page 438. So there are multiple worker threads, and they could run on different CPUs. And the worker thread would handle the queues for the task. So for each task, there's a queue, and the worker thread will serve for a particular task. And the idea of worker thread was described last time. It's a quite advanced model to achieve concurrency. Remember last time we talked about the basic, the most fundamental way to achieve concurrency is by what? By forking a child process to serve a client. So if there are 100 clients, then you would fork 100 child processes to serve them, and each process will serve one client. And however, if there are too many clients, you don't want to do that. You don't even want to do a thread, okay, per thread. I mean thread per client. So you could create thread for each client. But if you have too many clients, then it's still not scalable. So the better way is the worker thread model, where you don't bind a particular thread to a client. No fixed binding. And a client over the service time cycle could be served by multiple threads. Okay, it could be served by thread 1, and then thread 2, and then thread 3. Okay, and then done. So over the service time, it could be served by multiple threads, and each thread would just do one single task to handle the request in the queue of a task. In a queue belong to a task. Okay, so each thread will be dedicated to one purpose. That's what's shown on this figure. So there should be one more figure here. And before that, before creating those worker threads, there are some initialization. Here are some initialization before you really get into the worker thread model. And starting from installing a handler for signals, and do the initialization, turn yourself into daemon, and create some task managers, and then initialize the server with the configuration file and zone data files, and then wait for the signal. And then you get into the worker thread model. Okay, so for the zone data files, the resource record in the zone data file, it was on the data file, but then you need to, during the initialization, you need to read in the data files. You need to read in the data file into the memory. You want to keep a data structure, the resource record data structure, in your memory, not in the disk, not in the file, because if it's in the file, then it will be too late to access when you process a query. When you process a query, you want your resource record to be in the memory. And how do you organize the resource record in the memory? It's organized into trees. Well, actually, it's organized into a linked list. For each zone, it's a view. Each zone will be represented by a view with a zone table. Within each zone table, it will be a tree, the so-called break tree of resource record. And for a zone, particular zone, the resource record is organized into a tree so that you could search just like searching a tree. So that's a resource record. So now the resource records are in the memory. So if you want to look up in processing a query, you can just traverse the linked list and then traverse the tree to find the resource record you need. And then pass it back to the query initiator. Okay, there's a tool called DIG, Domain Information Gopher. It's a tool that can dump the resource records of this particular of a domain name server. So I can use this tool to dump a resource record, the resource records of that particular domain name server. Of course, I need to have the authority. I need to have authority to dump the resource, access the resource record. Okay, here you see the so that's the we send a question. So within the query, it says that the question is this: I'm asking for this domain, and the answer is this domain has this IP address, and this domain has 3 name servers, and this name server, they have these IP addresses. Okay, so it's organized in the same way as this. So question, answer, authority, and additional. So basically, just dump the basic resource record from that host.